Hello, ladies and gentlemen of Algebra 1. Hope you guys are doing alrighty. So today, we're going to go over the answers to this worksheet. Ooh, look, it almost makes the pen look like it's wiggly. If that makes sense. Anyway, we're going to go over the answers to this worksheet. And remember, I'm basing the exam off of this worksheet and the content that we did together, the radicals, the exponent rules, and the imaginary numbers. And we will review those again tomorrow, but for now I'd like to go over this worksheet. So, some of these we already did. If you know how to do them, you can skip around to the ones you don't. A ratio, which basically means a fraction, of good guys to bad guys, so good to bad, was 12 to 5. 12 to 5. Good to bad, 12 to 5. If there were 72 good, how many bad? So good to bad, 12 to 5, 72 to something. We don't know what that something is. So usually when you see two fractions like this, the mission is going to be to have to cross multiply them, and guess what? These are ratios, so that's exactly what we're going to do. So 12 times x gives us 12x. 72 times 5 gives us 360. Dividing both sides by 12, that ends up giving us an x value of 30. So that's just a simple setup with a simple answer. Now I need to grab my calculator real quick because I will need this in a little bit. And I think you'll be able to see the screen on the screen. Yeah. All right. Number 2. The ratio of yellow marbles to purple marbles was 13 to 4. There were 102 marbles in the bag. How many were yellow marbles? Okay. So for number 2 is a little weirder. So yellow to purple was 13 to 4. 13 to 4. If there were 102 marbles in the bag total, how many were yellow marbles? So we know that for every 13 yellows, there are 4 purples, which means if, let's say, there were 2 stacks of 13, there would be 2 stacks of 4. So for every 1 13, there's 1 4. For every 2 13s, there's 2 4s. For every 3 13s, there's 3 4s. So we know that these guys are all multiplied by the same number. So we could say 13 plus 4 would give us a certain amount of marbles in total, right? It would give us 17 marbles. And we could also say that if we had 2 13s and we had 2 4s, we would end up with 2 times 13, which is 26, 2 times 4, which is 8, and then we'd end up with we'd end up with 26 plus 8, which would give us 34. So we can see that for every stack of 13s we have another stack of 4s. So the idea is, oh, that was my phone. How many 13s plus how many 4s would give us 102 marbles? That's our little equation. So 13 plus 4, we already said was 17. So 17x equals 102. Divide both sides by 17. And we get 6. And that's going to be our answer. Weirder problem. Yeah. Doable? Yeah. Lisa and Jan, for number 3, found that 5 times the sum of a number and -2 equals 30. What's the number? So, they found that 5 times the sum of a number and -2. So we're adding 2 numbers together. So 5 times 2 numbers added together. A number, we don't know what it is, and -2, so x plus -2 equals 30. What's the number? So find x. All right. So if I'm multiplying both these numbers by 5, I can distribute my 5. So that's 5x plus -10 equals 30. I need to add 10 to both sides. So I need to get rid of this -10. So I do a positive 10 to both sides. These cancel. I get 5x equals 40. Divide both sides by 5. And x equals 8. And I'm done. Number 4 was similar, except for the fact that number 4 was more annoying. The product of a number and -7. So -7 times a number, -7 times x. So -7x reduced by 3, which means there's 3 less than we started with. The result equals is 33 less than, so reduced by 3 and 33 less than is the same thing. So we're going to subtract 33 from the end of this part. 33 less than twice the opposite of a number. Twice the opposite of a number. Twice means times 2, opposite means negative, and a number means x. What is the number? So if the product of a number and -7 is reduced by 3, the result is 33 less than twice the opposite of the number. What is the number? So we need to add like terms. So I like my x's to be positive, so I'm going to add positive 7x to both sides. And that if I'm bringing the x over here, that means I want to bring my other number here. So I'm going to also add 33 to both sides. So these 7s would cancel. Positive 33 and -3 would give me 30. Plus 7 minus 2, that gives me 5. And 33 minus 33 cancels out. So 30 equals 5x, divide both sides by 5. I get a grand total of x equals 6. Hooray. Number 5. I told you we're not having a question like number 5. So number 6. Draw a number line and graph the solution to x is less than or equal to -4. If these are giving you a headache, I would highly recommend you Google the difference between greater than, less than, all that jazz. Number line, they only give us one number, -4. I guess it's right here. X is less than -4, which means everything to the left is going to be shaded. It's also equal to -4, which means my circle is going to be shaded. I'm done. Number 7. 1.03 of 0.054 is what number? Of means multiplication, so I multiply the two numbers. 1.03 times 0.054 gives me 0.05562. And we said, I'm not entirely sure what Captain Melton's method was for solving these problems. So for me, on this exam, all I'd like you to do is type it in your calculator. But when he comes back, you might want to do it his way again. But for now, let's just do it this way. Okay, so number 8. Write both an inequality and a negated inequality that describe this graph. Well, let's start with just an inequality, which is basically what this problem was asking for. So this starts with 1, and it gets bigger. So x is going to be bigger than 1. So x is bigger than 1. The question is, does it also include 1? Yes, because it's solid. Here's my answer to number 8. It also asks for a negated inequality, which basically means, let's say the opposite of what this is saying. So you have an x and a 1. If this says x is bigger than 1, this will have to say x is less than 1. If this has an equals, this will not have an equals. So it's the perfect opposite. So this is an inequality, this is a negated inequality. And you got to do that. So it's negated. Cool. I need a new piece of paper. Number 9. If f of x equals negative x squared plus 3, find f of -3. If you have f of a number, that just means that this is going to become all of your x's. So you're going to substitute in whatever they give you for your x in the problem. So we had negative x squared plus 3. So now for every x we see, we're going to plug in -3. So negative 3 squared plus 3. This is a good song. So what's -3 squared? Positive 9. So we have positive 9 plus 3. What's positive 9? Negative 9 plus 3 equals -6. This is my answer. Yeehaw. Cowboy. 10. simplify, they give us two different problems. Once again, asking us to do some weird stuff with signs. For the first one, we have negative 2 to the negative 3. For the second one, we have 1 over negative 2 to the negative 3. All right, so the way I would recommend doing these problems to save you some headache is to put it all in your calculator. Remember that this is negative, this button. You don't want to hit minus, it's negative. So negative, and then on parentheses, negative 2, close parentheses, raised to the negative 3 power. This will save you a lot of time. If you don't have a calculator, though, we have to be able to do this by hand. So, what's negative 2 to the positive third power? Well, we have 4 is squared, and 8 is cubed. So it's going to be an 8. So negative 2 to the positive 3 would give us negative 8. So this is going to confuse you. You need to use your calculator. We get 0.125, and if we hit that, it gives us 1/8. So the answer to this one would be 0.125 or 1/8. Another way to think about this is to solve it by using our laws of exponents. So when you have a negative exponent, that means you need to bring it to the denominator. So this says 1 over negative 2 cubed. And this lets us work it out like this. So negative 2 to the third power is negative 8. So now we have 1 over negative 8. These negatives cancel each other out. We end up with 1/8. For this one, we have negative 2 to the negative third. If we want a positive exponent, we have to bring it to the numerator. So this guy's going to go up. So we end up with negative 2 to the positive third over 1. Negative 2 to the positive third gives us negative 8. We're done. You could just type this in your calculator as well. You just need to be super, 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 super careful if you're going to do that. Let's talk about number 11. So numero 11 says to simplify and factor if necessary. We get 6xy plus 36x squared y all over 6xy. All right. So can we summarize? Can we simplify anything in the denominator? Not really. Anything in the numerator? Well, we might be able to factor out some common things. So we can't factor out anything in the denominator. But is there any number that these two numbers have in common? Yes, there is. We could say 2. You could also say 3. But you could also just take 6, because 6 goes into 6 and 36. So 6 goes into both of them. Now, what is the least amount of x's they both have in common? They both have at least one x. And they both have at least one y. So we can pull that out of this top term. And so if we pull a 6, an x, and a y out of the first term, then we have nothing left. So we just have a 1. And if we pull a 6 out of 36, we're left with a 6. If we pull an x out of x squared, we're left with one of the x's. And if we pull a y out of the y, we're left with no y's. And now we're left with this beautiful problem where we can just go, and we're left with just 1 plus 6x, and we're done. Yay. And if you're feeling overwhelmed by any of these problems, feel free to rewind at any point and rewatch. Additionally, tomorrow we're going to have question time. So you'll be able to get into a Zoom call and ask questions. Number 12 says, factor the greatest common factor of 3a squared x cubed y to the 5th minus 6a cubed x to the 4th y squared plus 9a to the 4th x squared y cubed. Okay. Do they have any number in common? 3, 6, and 9? Yes, they all have a 3. What is the least amount of a's we see in this problem? 2. So we're going to take 2 a's out of every term. What's the least amount of x's we see? 2. So we're going to pull 2 x's out. What's the least amount of y's we see? 2. So we're going to pull 2 y's out. And then we're going to be left with some stuff. So if we pull a 3 out of the first term, we're left with 1. If we pull 2 a's out of 2 a's, we're left with no a's. If we pull 2 x's out of 3 x's, we're left with one of the x's. If we pull 2 y's out of 5 y's, we're left with 3 y's. Minus. If we pull a 3 out of 6, we are left with 2. If we pull 2 a's out of 3 a's, we're left with 1a. If we pull 2 x's out of 4 x's, we're left with 2 x's. If we pull 2 y's out of 2 y's, we're left with no y's. 3 into 9 gives us 3. 2 a's out of 4 a's gives us a squared. 2 x's out of 2 x's leaves us with no x's. And 2 y's out of 3 y's leaves us with 1 y. Simplified. How do you like them apples? Number 13. Write the answer with all variables in the numerator. That's x squared, y to the negative third, z to the negative 1, all over z to the negative 3, y, x to the negative 3. This is basically the problems that I was giving you a handful of in the last test. So we just kind of move everybody who needs to move, right? So for this problem, it says to write the answer with all variables in the numerator, which means all 3 of these bottom guys need to come up. So we had x squared y negative third z to the negative 1. But it said we're going to move everybody up. So if we move z to the negative 3 up, that becomes a positive 3. If we move y to the 1 up, that becomes y to the negative 1. And if we move x to the negative 3 up, that becomes x to the positive 3. And when you have exponents and variables all next to each other, you're going to add the exponents. Product rule. X squared times x to the third, you'd add the exponent, so you end up with x to the fifth. Y to the negative 3 times y to the negative 1 means negative 3 plus negative 1, which gives us negative 4. And z to the negative 1 times z to the 3, that's a 3 plus negative 1, which gives us 2. There's our answer. Everything's in the numerator. Now, is this simplified? No, because you don't want this y in the denominator, but that's not what the question was asking us to do. All right, let's look at number... I wonder how long this video is. I don't want it to be too long. Well, I can check, because I started this podcast when the video started. No, I changed the song by accident. Oh. Okay, it looks like we're almost... I can't tell. Maybe 15 minutes, maybe 20 minutes. That's still a little long. I didn't really want the video to be this long. Anyway, we might finish this tomorrow, but... for now, expand using the distributive property. Write all answers with exponents positive. That's what we were doing together. So they give us, for number 14, a to the negative 2 over b times b squared over a cubed minus 5ma squared over b to the negative 2. Fun, right? All right. So let's first start with this bit. So this bit is the first 2 terms. So we're going to multiply these numerators and these denominators, which means that for the first term, we just have a negative 2b squared over b a cubed. Minus, now we're going to multiply these 2 top terms and these 2 bottom terms. So now we have a negative 2, 5ma squared over b negative 2. Now we just have to simplify and use our rules. So I see a negative exponent here, so he's going to have to go down. I see a negative exponent here, he has to go down. I see a negative exponent here, he has to go up. So if I rewrite this, I have b squared over b a squared a cubed minus 5ma squared b squared over a squared b. Now I can just cross out anybody I have in common. So here I have 2 b's in the top, 1 b in the bottom. So this guy's going to get canceled out, and this guy will become b to the 1, because 2 minus 1 gives us 1. A squared times a cubed is going to give us a to the 5th, so we end up with b over a to the 5th minus 5 has to stay, m has to stay. These a squareds cancel. B squared over b would leave me with 1b in the numerator. There's my answer. This may be the longest problem we have. Now let's look at 15. Check this out, guys. This one's great. Can I get any closer and a little more focused? Apparently, that's going to be a no, dog. I just need bigger font, I guess. Okay. So, by adding like terms, right? So, anything to the 0 power is 1, so we can cross out anything to the 0 power. So now we're left with negative 2, x squared, x to the negative 1, y cubed, plus 4x, y to the negative 2, y to the 6, y to the negative 1, plus 3x cubed, x to the negative 3, y to the 4th, y to the negative 1. Gross, that's a long problem. All right. Good news is, it's a pretty simple one. So anytime we see exponents and variables next to each other that are the same base, we can just add those numbers. So let's do that. So negative 2. 2 plus negative 1 leaves me with 1. 4x. Negative 2 plus 6 plus negative 1 leaves me with 3. Plus x to the third plus 1 minus 3. So 3 minus 3 is 0. Plus 1 gives me 1. So I have 3x to the 1. 4 minus 1 leaves me with 3. So look, I ended up with the same exponents on all my variables, which means these are all like terms, which I can add them. 4 plus 3 is 7. 7 minus 2 is 5. I end up with 5x, y to the third. Long problem for a short answer. That is all we're going to do today. Your homework is to take notes on what I just gave you in your answers, and I want you to solve 16 through 20. And I want you to send me a picture of your completed work, either via text, Google Classroom, or text, Google Classroom, or email. And I need that today. So if you can send that to me today, you will get quiz credit for today's class. If you do not, then you do not get the credit. Yay. I hope you guys do great today. I hope you have a good day full of snacks and naps and hard work. And God bless you guys. I'm praying for you, as is Captain Milton. And let's get it.